Section 10-2 is called Measuring Angles and Arcs. The central angle of a circle is an angle whose vertex is the center of the circle. So looking here at circle C, angle ACB is called a central angle because the vertex of that angle, C, is the center of the circle. The sum of all of the central angles of a circle is 360 degrees. So the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is 360 degrees, and that makes a full circle. An arc is a portion of the circle defined by two endpoints. So AB, that would be this right here, is an arc of circle C. That's the portion of the outside of the circle here. And notice that it's denoted with two uppercase printed letters, so because those are points A and B, and instead of a straight line over it, as we did for a line segment, this has an arc over the top of it. So the measure of an arc is the same as the measure of its central angle. So if the measure of angle ACB is 85, then we say the measure of arc AB is also 85. So if it's a central angle, the measure of the arc is the same. Central, same. And notice we do, like we do the little m for arc for the measure of the, little m for the measure of the angle, we do a little m for the measure of the arc as well. A minor arc is an arc whose measure is less than 180 degrees. So in the diagram below here, arc AB and arc BC would be minor arcs since they are less than a half circle. A major arc is an arc whose measure is greater than 180. And because it's more than 180 and we have to think about which way we're going around the circle, we need to use three letters. So a major arc in this diagram is arc ACB. We start at A, go around the circle through C, and then stop at B. Since that's more than half a circle, that's considered a major arc. And then a semicircle is an arc whose measure is 180. Its endpoints lie on a diameter. So in this circle, AC is a diameter, so we can talk about semicircle AC or ABC. So here's a theorem. Two minor arcs are congruent if and only if their central angles are congruent. So if angle AMB is congruent to angle CMD, then arc AB, oops, that was not the color I wanted, is congruent to arc CD. And conversely, if the arcs are congruent, if arc AB is congruent to arc CD, then the measure of angle AMB is congruent to angle CMD. Adjacent arcs have exactly one endpoint in common. Arc AB and arc BC are considered adjacent arcs because they share endpoint B. And just like we had segment addition postulate and angle addition postulate last semester, this semester, since we're dealing with circles, we have arc addition postulate. If arc AB and arc BC are adjacent arcs, then the measure of arc AB plus the measure of arc BC equals the measure of arc ABC. This arc plus this arc equals the whole big arc. Okay, let's try some examples here. So given this circle, and I didn't denote the center of it, but that's okay, there's a lot going on there. We have to find x. Well, I'm given that this angle here is 180 degrees, and I know by this little box that this angle here is 90 degrees. So 120 plus 90 plus x is going to equal 360, because all of the central angles of a circle add up to 360. And subtracting, we get that x equals 150. So remember, that's the measure of that angle, but that's also the measure of arc BC. Now, the measure of arc AC, since its central angle is 120, the measure of the arc is also 120. And arc CAB, so that would be starting at C, going around through A, and stopping at B, is going to be 120 plus 90, using arc addition postulate, arc AC plus arc AB, or 210. Here's another example. In this circle, in circle P, AB, segment AB, and segment CD are diameters. And we know that angle CPB is 20 degrees. I'll try writing that in there. And angle DPE is 60 degrees. And we need to identify each arc as minor, major, or a semicircle, and then find its measure. Well, there are some of these we don't know, but I think we can figure them out. So, since CD and AB are diameters, then angle CPB and APD are vertical angles, so this one's 20. And we also know that AB is a diameter, so from A through C to B is 180 degrees. So if we subtract 20 from that, that means this angle over here is 160. And similarly over here, from A through D through E through B is 180. And here these two are 80, so this one is going to be 100 degrees. Now I think we can find the measure of each arc. So AD is a minor arc because it is less than 180, and its measure is 20 degrees. BE is also a minor arc, and its measure is 100. Arc BCA, so from B through C over to A, notice that that's actually a semicircle. And by definition, its measure is 180. And arc CDA is going to be a major arc because that's more than a semicircle. So from C through D to A, and that's going to be a semicircle, which is 180 plus 20, or 200. And arc ECA, that's also going to be a major arc, and its measure from ECA is going to add up to 280 degrees. Next concept, and that's the idea of arc length. Now, arc length is different from arc measure. Arc measure is in degrees. Arc length is a distance. It's a length between two endpoints along an arc. As such, it's measured in linear units. We're going to measure arc length in terms of inches or centimeters or meters or miles, a unit that we can measure with a ruler or a tape measure. And it is a fraction of the circumference of a circle. One way to think about this is I kind of like to think of arcs as like the crust on a pizza. Well, if you were to take a tape measure and lay it on the crust of the pizza and measure around how many inches the piece of crust on your slice of pizza is, that's what we're talking about with arc length. It's actually a fraction or a piece of the circumference of the whole circle. And here's the formula. L is the letter we use to stand for arc length. X is the measure of the arc, or, if you have to, the measure of the central angle, same thing. X over 360 times 2 pi r. Remember, 2 pi r is the circumference of a circle. So I'm saying what fraction of the circumference of the circle, that gives me the arc length. Let's try a couple examples here. If the radius of circle P is 5 inches, and remember, I need to know the radius, or I could use the diameter of the circle, because I need to use that to plug it in for the circumference formula. So if the radius of this circle is 5 inches, find the exact length of each arc. So the length of arc AB is going to be the measure of that arc, which is 120 over 360. In other words, that arc AB, is 120 360ths of the entire circle. And I'm going to multiply that by the circumference, which is 2 times pi times the radius, which is 5. Okay? Or, well, actually, I can reduce that, can't I? 120 over 360 is actually 1/3 times 10 pi. And if I want the exact answer, remember I need to leave pi in my units, so that's going to be 10 over 3 pi inches. And please do not write 1/3 as 0.3. It's not 0.3. It's 0.3 repeating, but we can use a fraction here, and I would prefer that. BC. Notice that arc BC is actually going to be 90 degrees because angle BPC is a right angle. So the arc length is going to be 90 over 360. Okay, look at the picture. Isn't that right angle 1/4 of the whole circle? So basically this is going to reduce to 1/4. And then we had actually figured the circumference of the circle is 10 pi. So 90 over 360 is 1/4 times 10 pi, reducing that, 2.5 pi inches. Remember, what arc length is if I could take a tape measure and measure how far it is from B to C, what that distance is. And the length of arc ABC. Arc ABC is 120 plus 90, or 210 over 360 times, I'm going to take a shortcut here because I've already done it twice, the circumference is 10 pi. And plugging into your calculator, you can do 210 divided by 360 times 10. Don't put pi in the calculator. 210 divided by 360 times 10. Math, enter, enter, is going to give you 35 over 6 pi inches.